with state-of-the-art machines and real people who really care. Meet one of the top Swiss screw machine shops. This is Turn Dynamics.
I'm a pretty modest guy, but our clients tell us that we are the Cadillac of the industry. We can do very complex geometries of different sorts, so we can do milling and we can do threading, all on the same piece of equipment. And so a lot of times that separates us from just a mill house where they're just milling parts. We can turn, we can do cross holes, we can do cross work, we can do knurling, we can even do etching. So we can even engrave, we can put numbers, words, we can write whatever you want on the part. And those parts, we drop them complete right off the machine, no secondary operations.
Turn Dynamics, your Swiss machining gurus. Here's Brian.
Hi, I'm Brian with Turn Dynamics, and we do precision CNC screw machine parts like this. We're made in the USA, which is something to really be proud of. We're a small family-owned, woman-owned family business. There's about 9 employees. We run 2 shifts, and that way we can maximize our output. So we have some 7-axis machines, single spindle machines, and then we have 9 single spindle lathes and 2 multi-spindle lathes. Yeah, we have bar feeders on all the Swiss machines, and that allows us to run with less operator intervention. Multi-spindle machines do not have bar feeders on them, so the operator would manually load material. We machine anything from 3mm diameter up to 32mm diameter. Most of our part sizes are 10mm to 20, in that range. So volume-wise, it depends somewhat on the complexity of the part, but typically we don't do things less than 10,000. So 10,000 is kind of on the Swiss machines. On the multi-spindle machines, I mean, we got multi-spindle machines that can make over 10 million parts a year. This would be one of the smaller diameter parts. So this is 1/8 of an inch, which is 3.125 millimeters. This part's about 27 millimeters in diameter, but our machines can go up to 32 millimeters. So Swiss screw machining is perfect for parts like this because you can support the part right where you're working it. So you're supporting the part as you're feeding the bar out. So wherever your tool is, you have a lot of support underneath it. Whereas if you were clamped way back here and trying to machine out here, you would have a lot of deflection, variation, chatter, and a lot of other issues. So the tolerances for diameters will hold on an OD. We can hold plus or minus 10 microns, which is plus or minus 4/10 of a thousandth of an inch. We'll hold roundnesses in the sub-micron range, so below 1 micron. So this right here is a flash suppressor. This goes on the end of a rifle, and it has a lot of pretty detailed features. There's a thread in the ID. There's an external milled flat for a wrench. There's milled slots, which we have to come back and deburr, but we do that on the machine, so we save a secondary operation. And then we do some boring on the inside. So this is a pretty detailed part. So this part right here, it looks very straightforward, but it actually has a feature on the face where we're holding a 4 micron flatness. We have to do a burnishing operation, which is cold working the surface. We do that in the screw machine while we're machining it, so we can produce this part in 7 seconds, and we can hold a 4 micron flatness on the top, which is typically a grind tolerance. Typically, we are able to hold grind defect rates. We've heard that the industry rate is typically around 5%, but we are less than 1%. We're around a 0.5% defect rate. So when it comes for design for manufacturability, we do work with the customer, and we'll give them feedback, and a lot of our customers are receptive when they can be, but I have a Six Sigma background, so design for manufacturability is a huge thing for me, especially because I'm involved with making the part. So I can give very good feedback, and when you have that kind of relationship with your customers, it's beneficial for them too.